Alright, so in algebra today we are starting with chapter 1, section 1. This is operations on real numbers. So we are going to be determining if numbers are rational or irrational. So to start, I kind of gave you this chart to look at. It actually makes it very easy to see the difference between rational numbers, integers, whole numbers, and we'll talk about that in a second. So rational numbers is a number that can be expressed as a ratio. And it's going to be expressed as A over B, where you can divide A and B. Sorry, you couldn't see that. So some examples of rational numbers are actually all these examples here. So we have integers, like -2. We have a whole number or natural number, like 5. We have repeating decimals, for example. And then we also have some fractions because they can be written as fraction form and also divide to give us a terminating decimal or a repeating decimal, so that makes it rational. All right, irrational is a number that cannot be expressed as a ratio. In the form of A over B. Okay? So, for example, let's say you have the square root of 2. If I wrote this out, it would be 1.41421, goes on and on and on, does not terminate, meaning stop, and it does not repeat. It repeats by continuing on, but it's not repeating a pattern. So that means it's irrational. So if we look back at the chart, the pi symbol, pi is irrational. It keeps going and going and going, no pattern. Same with some of these square roots. So that's an irrational number. One thing I do want you to notice, whole numbers and natural numbers, the only difference here, a whole number includes 0. Natural number does not include 0. So it's all these whole numbers except for 0 for natural numbers. Just a little thing you need to remember. All right, so down here, state if the numbers are rational or irrational. And you know what? We're also going to state if it's an integer, whole number, natural number too. So 5/8. If I divide 5 divided by 8, it's going to give me an actual decimal. It's not going to be repeating without a pattern. It's not going to terminate, or it is going to terminate. So this is going to be rational. And it doesn't fall in the integer portion or the whole number or natural number because it is a decimal. So that's going to stay as just a rational. It's not going to be any of these others. Square root of 7. When you do this in your calculator, you will get irrational because it is a decimal that just has no pattern. It just keeps going and there's no pattern. -3. Well, first of all, we know it's rational. And it is something else. The only thing it could be is an integer because it has a negative sign. Square root of 36. Well, we know that's 6, so we know that's rational. It's also natural, whole, and an integer. Okay? So you are going to have some questions like that on some of your homework. You will see it on your test as well. Flip into the other side. comparing and ordering real numbers. It is easier to compare numbers when they are in decimal form. You always want to convert it to a decimal. Always, always, always. So with these, you are going to use a calculator. So if you have a calculator at home, hopefully you're using it. I want to change these all to a decimal. So 40/11ths. If I change that to a decimal and I round it, it's going to be 3.63 repeating. Then we have the square root of 324/36. When you simplify that, you should get 3. And then square root of 10 is 3.162. And it keeps going and going and going, so we'll just leave it like that. I just want to compare the tenths and hundredths place, so I'm not going to write the rest of these numbers. All right, so if we're making a number line to compare these, it looks like we have it between 3 and 4. So I'm going to say this is 3 and 25/100ths, 3 1/2, 3 and 75/100ths. So obviously we have 1 at 3, which is this guy. That's our smallest. So I'm going to put 324. I'm just going to rewrite it. That goes with him. That's our least. Then we have square root of 10, because it was 3.162. So that's going to go somewhere over here. Square root of 10. And then our last one is 40/11ths, which is going to be 3 and 63/100ths. So probably around here somewhere. So now we have it in order from least to greatest. There will be problems on your homework where you have to put them in order from least to greatest as well. Okay, this last part, these are some rules for when you are doing operations with rational and irrational numbers. So when you are adding and subtracting rationals, you get a rational answer. So for example here, if we add these fractions, first we need a common denominator. I can change this 3 to a 6 by multiplying it by 2. This turns into 4/6 plus 4/6, which equals 8/6, which turns into 4/3, but we need a mixed number, 1 1/3. As you can see, rational, rational equals irrational. Same for subtraction. Moving on to rational times irrational will always equal irrational. So if I multiply here, I'm actually going to do some cross canceling here. 2 divided by 2 is 1, 6 divided by 2 is 3, so I get 4/9. That is rational. If you take a rational, add or subtract an irrational, here's our irrational, here's our rational. If you add them together, you should get an irrational number. You would use your calculator for this one, and you would get a decimal that keeps going and going and going without a pattern. So that is true, it's irrational. And then this last one, a rational times an irrational. Now I'm going to multiply the two, irrational and rational. When you do that, you still get an irrational number, which is what it says it would be. So just some rules to follow to help you figure them out. For the last part, simplify and determine if the number is rational or irrational. Well, we could actually multiply it out, but this is irrational, this is rational, so I already know by looking at the rule, it should be an irrational. And if I actually multiply it out, it would be 1.102, and it keeps going and going and going and going. All right, for the next one, 4/5 plus 2/15. Well, this is rational, this is rational. If we add two rationals, we should get a rational sum. I'm gonna write rational because I already know it's going to be. But if I do add these together, if I change this to 15, I get 12 fifteenths plus 2 fifteenths. That equals 14 fifteenths, and that is rational. Okay? So this should have been a little bit of a review, not much new. But now that you have the notes and you watch the video, you are able to complete the worksheet. So make sure you go back to the folder and find the assignment and submit it. So this is your time to work on it now. Hopefully this video was helpful for you, and I will see you tomorrow.